Microservices have gotten really complicated to build and maintain. Not only do you have to build the application, but you have to figure out an API gateway, a load balancer. You have to figure out how to deploy it, what data store you want to use, how to do canary management and monitoring and logging. There's lots and lots of use cases to handle, and I think it's one of the reasons why microservices have gotten such a bad rap over the years. But what if I told you there was another way to go about doing it? And just by rethinking some of the core ideas behind microservices, we could possibly be using very, very few technologies to accomplish the very same task. So today I'm going to rapid fire go through a lot of these use cases and how a technology like NATS can help solve a lot of them. And I'll give you some practical examples as well as an overview of all of these different parts of a microservice architecture. So let's get into it. But before you do, if you're new to this channel or you know somebody who would like it, be sure to like and subscribe and share this video with somebody else. Creating this content is so fun for me, and I hope it's valuable enough for you guys. So just let us know by liking and subscribing to this content. It really helps us out. Okay, on with the video. So like I said before, we're going to be kind of going over this concept of rethinking microservices. Just as NATS has kind of rethought the connectivity layer, we want to zoom in on this idea of building out microservices, because microservice architectures, it is a lot to deal with. You have API gateways, load balancers, discovery, canary management, logging, monitoring, config management, data store, deployment. All of these things are kind of like I would say the bare bones or the bare minimum that a microservice architecture needs in order for these things to be able to kind of run efficiently. And being able to put all of this on a single team is really, really difficult, which I think is why there's been a huge rise in platforms and internal platforms within companies to try to create golden paths for a lot of these. But we've seen mixed results, right? And so what I want to try to propose today, and this is a fun exercise, it doesn't mean you have to adopt it for everything or to use every use case, but I always like to aim to simplify things. And so what I'm going to attempt to do today is take a look at a lot of these use cases and see how they translate over to how NATS can solve that use case. And quite possibly you can architect a microservices architecture that is a lot leaner in terms of infrastructure, but still has all the flexibility and gives you a lot more velocity because there's really one technology to learn or a couple technologies to learn instead of dozens. And so today we're going to be looking at API gateways, load balancers, service discovery mechanisms, and how to accomplish all of these things in NATS. So let's talk a little bit about location transparency. So the idea of location transparency is kind of taking this mindset of who do I talk to, IP addresses, domain names, et cetera, thinking of things as services that I must talk to, and starting to shift to, well, what do I want to talk about? And this is really one of the core tenets inside of NATS, is this idea of location transparency, that you can start having a conversation about a particular topic or subject without having to know the location of who you're chatting with, and not really even having to care too much about it. And so rather than going through and, configuring domain names and even API gateways to try to abstract that a little bit, you still have some leakage in terms of where things may be located. And it makes things like failover as well as just like general balancing between a lot of these microservices and locations, a very difficult thing to do with traditional technologies. And so shifting from this who do I talk to what do I want to talk about really is a fundamental shift that I think makes a lot of these use cases a lot simpler to deal with. And you're going to kind of see this as a through line in this video where I talk about location transparency kind of being the core of what drives a lot of this. And so instead of, domain names, think things like subjects, math.add, payments.create, search.add_index. These are all the core where you just need to know the NAT server that you connect to, and then you just want to know what you want to talk about. And quite simply, that's our basis of how to design a microservice architecture around NATS. So let's talk about that in light of something like an API gateway. So API gateways traditionally have been there to accomplish a few things. They're really there to try to aggregate, endpoints of microservices all together. So there's like one single API, and that gives us a couple benefits, right? We're able to have one HTTP endpoint or WebSockets endpoint to interact with multiple services, which is great. And we also have kind of a single layer that acts as maybe like an authentication or authorization gateway. gateway, where we can have one single layer of security that kind of covers all of our bases there. And this is great both for internal microservice communication as well as external microservice communication. Think like having a developer API or something like that. And one thing I want to talk about is that NATS actually just naturally does this. You have clients on one end that are all connecting to this NATS server, and they're wanting to have conversations about particular subjects, and NATS is the broker between those subjects, being able to kind of connect them together. And when we layer on a couple more features, you could start seeing a lot of the value that NATS has kind of being this API gateway of sorts. So before I dive into some code just to illustrate this, let's talk about a couple more concepts, and then I think things are going to start clicking a little bit more. Next up, let's talk about load balancing. So sometimes you'll have an API gateway that does load balancing, but typically you'll bring in something like an Nginx or an Envoy, some sort of reverse proxy on HTTP to kind of load balance the requests between multiple nodes. And these load balancers have to have knowledge of the nodes kind of coming up and down. So you have to have some sort of process to facilitate updating those configurations or detecting when something goes online. So this typically can work with in tandem with a service discovery mechanism, which is just again another piece of infrastructure technology to layer on top of it. But really at its core, what a load balancer is doing is it's taking nodes that can all serve the same requests and it's balancing between those. Where things get a little bit interesting, especially with how NATS handles this, is yes, NATS has load balancing just built in out of the box with a feature called queue groups, and I'll show you in a sec how to use that. But additionally, these queue groups work across multiple geographies, multiple clusters, into the supercluster realm, where it's actually going to be very intelligent about how it routes its requests. If you make a request to the math.add endpoint, it's going to first try to see if there is anything that can respond to that math.add endpoint in its local cluster. And if not, it's going to search outside of that cluster. And just with that simple mechanism, you actually get a lot going right there. Not only do you get load balancing between multiple nodes, but you get automatic failover in case a region goes down that's happens to run those microservices. And you don't really have to run any other technology to try to do the discovery and then send that over to the load balancer and make sure that those interact together. This all just happens inside of one piece of infrastructure to kind of manage all that is really, really nice. And I'll kind of show you exactly how this works and especially how it interacts with our kind of microservice library that we've created. The third one that I want to cover is service discovery. So typically you'll use something like a console or maybe even the Kubernetes service API stuff to be able to create service discovery or a way to kind of detect when nodes in a particular service come up and come down so we can route to them, so we can discover which ones we need to talk to, what their DNS address is, even get a little bit of health checks and stuff like that. This idea of service discovery is typically reserved for another piece of infrastructure. And this is actually also something that we've kind of built on top of NATS server, this idea of services. And the really neat part about this is the NATS server actually doesn't have a concept of services. It's not like you go register a service with a NATS server. In fact, we just use convention in order to create a service discovery mechanism. And because we have this idea of location transparency, we also have this idea of end-to-end communication. A client can simply send a message that's like $serve.info. That's exactly what it is. And what the NATS server is going to do is it's going to reach out to anybody who's subscribed to that subject, and they're going to self-report back any information about them. This could be what endpoints they have. It could be, what kind of stats they might have, how many requests have been served, how many errors are they getting. So you get this kind of a lightweight discovery and monitoring of your microservices for pretty much free. I'm going to show you exactly how to do that today. And this is the real power of NATS, is that you can create infrastructure like this almost out of thin air based off of certain patterns within NATS itself. And it's really a beautiful way of being able to create a lean microservice architecture without having to kind of shovel on 12 different services. So before we move on to a couple more use cases, I want to dive in and show you guys how service discovery and load balancing, how the location transparency works, and how we can kind of simulate this idea of an API gateway within NATS. So let's get started with that. I created a little microservice called math that has like things like math.add, math.subtract, multiply, divide. You get the picture. And this is a little microservice written in Go. And I'm not going to go through all of the code or anything like that, but the main thing that I want to show you is this. So we have a little library called Micro, and it's in many of our client libraries already. So you have access to this even if you don't write Go. And it's part of the core kind of SDK. It might be in a different module or package depending on how your language of choice works. But the core of it is that you're able to spin up this idea of a service and give it a name, a version, and you're able to then add some endpoints or handlers to these. And so you could see I have the math group and then the add handler there. And I can give, any sort of metadata that I want. So I made this up: description, format, request schema, response schema. You could see by convention, you could actually do a lot of really interesting things. Maybe you don't need a schema registry if all of the particular microservices are self-reporting their own schemas by convention. And that's something that you do as a convention inside of your organization. So again, a lot of really fun things to fiddle with and play here. But yeah, you basically just add your endpoints and connect to your NAT server, and you're ready to go. You're ready to kind of handle all of these requests. And what you get out of that is you get load balancing, you get the self-reporting of stats and service discovery, and you get kind of handling of your requests. So let's kind of check this out. We'll run a few instances of it, and I'll show you what I mean by like service discovery, load balancing, etc. So I'm just going to quickly fire up 3 of these using xargs. And now there's 3 of these microservices that are listening on math, add, subtract, multiply, and divide. I'm just going to go over here to this next tab, and I'm going to be using a nats CLI command saying nats micro list. And what that's going to do is it's going to list out all the microservices that I have. And so there's a service called math, and there's 3 instances of them, and they've all been given a unique ID. And now we have a description that says a calculator service. If I wanted to learn more info about this particular service, I could say nats micro info math. And what this is going to do is going to return, in my CLI, it's going to return a lot of info about this particular service. So we know it's called math, and that it has a particular ID assigned to it. And this is the ID of the actual instance that decided to respond to that. It's actually load balancing the info response, which I think is pretty cool. It gives me a description and a version, and then it's going to give me the information about these endpoints. I have one called add. It says math.add, and it even has all the metadata there for me. So if I wanted to kind of pull off the JSON schema for request and response, I absolutely could do that. Same thing with subtract, multiply, and divide. And this is just what the nat CLI outputs. If I actually run this again with a JSON flag, you can see all of this is just pure JSON. So you could build your own tooling around this if you want. You could build automations around this. There's like the sky's the limit in terms of what you could build, and it's all very open and easy to access, which I think is awesome. So that handles kind of the service discovery aspect of it. We can do it, nats micro list, nats micro info to discover more about these services. And you can see we already have a lightweight service discovery mechanism in place. Now, the other thing that this microservices library gives us is it gives us automatic load balancing. So I'm running 3 of these, and I can simply just say, nats request, math.add, and I'm just going to pass in nothing as a payload, and it's going to give me unable to parse request. But the cool part is this is going to be split between all 3 of those that I set up. So if I go ahead and say, nats micro list or nats micro stats for the math service, it's going to show me that it served 4 total requests, and that they've been split fairly evenly between the 3 nodes that exist right now. And so again, load balancing is happening automatically out of the box. Like, I haven't seen a technology that is handling like API gateway, load balancing, service discovery, and the actual communication mechanism at hand all in one place. This is the first time I've seen this, and I think it's a really, really cool setup for a lot of microservice architectures. Let's hop over to our next kind of slide. Canary deployments is another thing that's really common in microservice architectures, and if you don't have something like this in place, you're probably having a hard time with your architecture, because having microservices dependent on each other and trying to roll out updates can be a huge pain. But if you do have a good Canary system, it makes this quite a bit easier to manage, especially if you can also kind of trace out who's calling what and know when you could properly sunset stuff. And again, there's a lot of technologies that can do this stuff or altogether can do this stuff. But I think this is a really simpler alternative to be able to handle this in a really elegant way while still giving you all the transparency and all the features that you may want here. And so quite simply, to handle Canary deployments, there's both configuration that exists in the NATS server side, and if you're using the JWT-based auth or any sort of multi-tenancy, you would configure this kind of on the account side, which is great. So you have flexibility here, depending on your model. But the idea of Canary deployments is that you might want to route a certain percentage of traffic or all of the traffic to a different set of instances of a microservice, a V1 versus a V2, and still not have to update any sort of the clients or callers of that particular microservice. One way we could do this is by using the subject mappings like I just shown. And it's really easy to do. You just set mappings, math.star, I want this to map to math.v2.star or whatever it is, and a 50% weight. So let me show you exactly how we can do that. So I'm going to spin up a brand new microservice that will represent kind of the version 2 of math.add. I'm going to say nats reply math v2 dot add, and we're just going to echo the request. And so it's not really doing any sort of addition, but that's totally fine. And what I can do here is I'm going to close out my NATS server, and I'm going to spin up a config here called subjectmapping.conf. And we could take everything from math.greater than, and we could simply map it to math.v2.greater than, and we'll just map 50% of the traffic there. And so I'm going to use this configuration file in my NATS server. So I'll just say config subjectmapping.conf. And now we have a brand new NATS server spun up with that new mapping, which is great. And if I start making requests, NATS request math.add, and this time I'm actually going to send a payload. I'm going to say that A equals 1 and B equals 2. This is just a little JSON payload. What I'm going to see is sometimes 50% of the time I will get the response just echoed back to me, and the other 50% of the time I should get a result, which I just got right here. And so this is actually splitting the traffic between version 1 and version 2 of that particular set of microservices, which is really, really great. And so you can do Canary deployments really easily. Subject mappings are really cool. I won't go into the full details, maybe in a future video, but you can do things like set mappings for certain clusters, really have a lot of fine-grained control over the subjects and how you map them. And so this is a really, really cool feature for Canary deployments, and it's really, really easy to work with. Moving on to something that might not seem suitable for NATS, but bear with me here because I actually do this all the time, and I think it's a really, really cool way to kind of create a log tap mechanism for NATS. And NATS is actually really well suited for a log tap mechanism because you could have something that's very distributed and you want to be able to kind of dig into a microservice, maybe really deep into the stack and pull out their logs. And this is a really good way to do it in real time. And I'm not necessarily suggesting that NATS just be your Logstash service, but we've certainly seen it work at a very high scale. And it could be something that really works well, especially for debugging and things like that. So the idea here is that your microservice will simply just output its logs to core NATS. And you could configure this so that you're not sending a ton of logs, or that you're buffering, or that you're even, in some senses, wanting this to just be kind of a break the glass switch that you turn on. And I'll show you that in a sec when I cover configuration. But you have a service that's maybe publishing all of its logs to NATS, and not necessarily a jet stream, but just NATS core. And so you could have a client, whether that's your CLI or whether that's a tool that you're building, that can then subscribe to those logs and do whatever they want with it. And because it's subject-based addressing, you can key off of, the instance of the service or the log level or, really any other, the region, really any other attributes that you might want to. And now you're having this kind of really cool filtering and indexing if you're using Jetstream mechanism for your logs. And so you're kind of taking that whole log service out of the way and just using pure Nats and Jetstream to be able to accomplish this. So let me show you what I mean. I have this math service running, and I'm actually outputting logs via this math service. So I'm going to go ahead and go back to this Nat server, and I'm just going to remove that subject mapping that we just used so that we have a clean demo. And I'm going to say nats sub math.log greater than. And so now I can take a look at any logs that come in when I make requests. So I'm going to make a request at math.add. And as you can see, we're not seeing any logs. And the reason being is I've actually set the log, the log level to output to Nats to actually just show me errors. That way I'm just not slamming the Nats, the Nats server with all of my logs that I'm doing. But if I do send it something that's going to result in an error, like just passing a blank payload, you'll see that we are getting full-on logs, full-on structured logs actually. And so you can do a lot of really cool stuff with this. And I even in the subject get the instance that has logged it. So I can filter on that. I can even put this into a Jetstream if I wanted to. In fact, let's go ahead and do that. I could say nats stream add defaults, and we want the subjects to be math.log greater than, and we want to call this stream math logs. Let's wrap this in a string. And there we go. We have a stream created. So if I now start making requests to math.add, those are going to be sent over to that stream, which is really, really cool. So there's lots of really neat things that you could do just all inside of Nats, all in one place, that could be really useful for logging. On to our next use case, we have monitoring and observability. And I want to cover kind of two distinct use cases here. One is kind of on the, hey, how do I monitor my applications and get kind of an idea of what's up and maybe if there's any errors that are occurring and things like that. But then I also want to be able to do maybe some more tracing, like being able to fire a tracer bullet and see, where the message ended up. And so I want to talk about both of these use cases real quick. But the idea of being able to do monitoring and observability inside of Nats is this, it's this same idea around our microservices API, where I might want to just send out a message to say, give me all the stats for those of you who are the math service, and those will receive the request and respond back, and you'll get those 3 messages back, one for each instance. And they'll tell you more about themselves. And this can be really cool as a way to do some sort of scraping and then putting into a time series database, or even just in real time being able to get those stats. I think it could be really, really useful. And so the way that works is that, we do the same thing that we essentially did here. We say nats microstats math, and that's going to give us all the info on those particular math handlers, which is really, really cool. And just as I mentioned before, you can even just throw the JSON flag on here and you get JSON back for all of these. And so if you want to do something similar to like a Prometheus scrape or anything like that, you can get this very, very easily without having to have some sort of index of all of the URLs of these individual microservices. This whole scatter gather pattern is super, super useful in a lot of these use cases. And I think we're just at the beginning of figuring out how to leverage these really, really well. The other thing that I wanted to talk about when it comes to monitoring and observability is something that's actually coming very soon in NAT Server 2.11, and that is tracing. So the idea of a trace is that you can add a header, or you can configure your NAT server to accept, a trace parent header. And what that will do is it will emit on a particular subject all the information about what happened to this message as it entered the NAT server. So what time it entered in, who sent it, whether or not it went through Jetstream, whether or not it went over an account boundary, and then also its egress, what it left the NAT server being, who it was delivered to, et cetera, et cetera, et cetera. So it's going to give you information about the server that accepted the request, information about the request itself, and then any events about that message that that relate to it. And so I'm going to demo this really quick because this is a brand new feature. It's not even in the latest version of NAT Server. It's coming in the future version of NAT Server. But if you want to check this out, you can get nightly builds, and it's super, super fun to play with. So in order to do this, we need to decorate our message with a particular pattern. And so here I'm going to say nats request math.add. Nats trace destination is trace. And so what this is saying is that if I listen to the subject called trace, it's going to end up emitting all the trace information into that trace subject. So before I send this, this message, I'm actually going to say nats sub trace. And when I start sending this, you could see that we get all of this trace information here. I'm going to modify this to say raw, so we don't get any other stuff, and then we'll just throw it into JQ so we get some nice formatting here. So I'm going to go ahead and send this request to math.add, and let's see what kind of information it gave us. So we get information about the server, that it's Jeremy's Mac Studio. It has a server ID, what version of the server it is, also information about its request, and all of the events. So we have an ingress event and we have an egress event of who sent it and then who received it. And if this, for whatever reason ended up in Jetstream or crossing an account boundary, we'd also get events here too. And so this is just the beginning, and I know we're going to be building a lot more tooling and resources into how to get stuff like this into like open telemetry so that you could like analyze it and visualize it. But I think this is a huge step in the right direction for getting like really, really good monitoring and traceability inside of NATs. Okay, another portion that I want to cover, because it's a huge topic and I think it's where a lot of folks get stuff wrong inside of microservice architectures. It has to do with the authentication and the authorization. And in my mind, the closer you can get to a more unified architecture or a more unified way of doing authentication and authorization, the better. And I think NATS has a really good model for authentication and authorization. And so just as a high level overview, I do have a video on this that I'll link in the description below if you want to learn more about it. But in terms of microservices, we have authorization driven by JWTs or JSON Web Tokens, and that kind of shows all of the stuff that you have access to, whether you're allowed to, have access to this subject or not, or, to subscribe to this subject, or whether you're allowed to publish to this subject. And so all of this stuff is defined in claims inside of the JSON Web Tokens. And then we use these things called N keys that are these public-private key pairs that are used to authenticate a particular user. And we use those in combination to be able to create a really cool zero trust construct-based authentication model. The really neat part about all of this is that they're subject-based. So like everything in NATS, we have messages, and those messages have subjects, and they can be filtered, they can have wildcards, all that kind of stuff. And all of the permissions are also driven by subjects. So basically, you are restricted to, what types of subjects you're allowed to publish or subscribe to. And this makes for a really, really powerful and fine-grained permissions model. Because it's more decentralized in nature, it also makes it really highly scalable because we don't have to update servers every time we want to create a user. In fact, it's just signed up the trust chain, and it's delivered to the client who needs it, and the server will accept it because it's verified that chain of trust. So the thing I love about this is it gives you a single security model for being able to authenticate all of your microservices to each other, and they can use one credential to access all of those things. Okay, let's talk really quickly about config management. So config management in NATS can actually be really cool because we could use our key value stores to help kind of define sets of configuration. And at any time, those set of microservices can then, in a secure way, look up the configuration that they need. And also be able to watch for changes to that configuration. So now you have these apps that don't need to be restarted, pods don't need to be restarted. You can simply just have them watch and update whatever configuration they could live update for that particular application. And so let me show you an example of that. If we go back to our logging example, we can see that we had subscribed to the math.log subscription, but we were only showing errors. We weren't showing any sort of like info logs or anything like that. And that's because I set the log level to error. But the cool part is a lot of these applications are actually driven by a KV based config. So I can say nats kv, kv put config. So this is our config bucket, and I'm just going to say math.log level. And let's see what happens when I set my log level to 0. So now we immediately received another log line that says that our log level was set to info. And if I make some more requests to our math.add endpoint, let's add 1 to 2, not only do we get our results here, but we also get logs saying that the add handler was called. And so you can kind of see in combination with, sending log messages at a core Nats level that you could also kind of use this as a log tap that stays efficient. So you're not just like sending all these messages to a Nats server that aren't going anywhere, but you can really kind of turn this up or down depending on your needs and use cases. And once again, all of this can be routed into a stream if you wanted to like analyze those logs later. And it's all very ad hoc and flexible, but also really performant, which I think is a pretty cool attribute. Okay, there's only a couple more things to cover, but I think they're worth covering. And some of these may seem obvious, but if you're building a microservice, you're likely going to need to use a data store. And it's very easy to reach for like a SQL database. And, I'm not going to fight anybody on that. SQL databases and relational databases have their own, use cases, and they cover a wide swath of things, and they're really easy to set up and to use. But I would say that if you want something that is a bit more distributed, SQL databases and relational databases get a bit tougher to scale out. And so if you do want something that uses a same security model as your microservices and that is, on day 0 ready to replicate and scale out globally, you might want to consider using, Jetstream for some of your data storage needs, whether you're doing streams for like stream processing and consumers, or you want to, replace something like S3 or MinIO with Nats object or Jetstream's object storage. You want to replace Redis with our key value stores, which, by the way, my last video was all about KV stores. You want to go check that out. And you get benefits of global replication and also this shared security model. So your one credential to connect you into the Nats cluster can drive your access to all of these data stores, all of these access to their microservices. And in a sense, it's kind of this one big API gateway that we talked about at the beginning to drive all of these things and unify it into a single mesh. And so definitely consider checking out Nats Jetstream's data stores because you could actually accomplish a whole lot with them. And lastly, I wish I had a demo for this, but this demands its complete own video. But deployment is another thing that's huge for microservices. And a lot of folks will use like a Nomad or a Kubernetes or even one of the dedicated cloud providers' container runners to be able to do that. But we've been working on something here at Synadia really about how do we deploy applications that run really close to Nats and try to take as much advantage of Nats as possible. And we found that because we're handling all these other use cases, things like the data and the communication layer and the authentication layer, what if we took it one step further and tried to implement, how do we run workloads with all of these things together? And so I just wanted to show a little preview before we create some more videos on it that we have a component called Nex that we've been working on. It's still early days, but it's something that makes it very, very easy to, once you've connected into a Nats cluster, you can spin up these nodes. These are virtual machines here, but you can spin up these Nex nodes that will allow you to deploy to them. And you can use Nats as your control plane to be able to say, hey, I want to run this binary or this, this serverless, JavaScript, right there in that node. And so it's a very easy way to be able to just like place workloads in those nodes, to collect logs about them, to set environment variables for them, and to run them in a safe environment because all of these are run inside of Firecracker micro VMs. So for those who are building applications that are multi-tenant, that need that, strict layer of isolation, or building a serverless platform, the Nats execution engine actually gives you so much out of the box with very, very little infrastructure. We're talking you need to run a Nats server and you need to run a Nex node, and you're pretty much there. So I think this is a really, really beautiful way to kind of wrap up how much more simply you can create a full microservices architecture end to end. And I'm not claiming that you're going to necessarily be using all of these components to be pure Nats. I mean, that would be really cool. Sound off in the comments below if you're trying to do that. But this is kind of hopefully a way to try to rethink how all of these things work, and the fact that you don't need a million different technologies in order to accomplish a microservices architecture. In fact, you can use very few and get very, very far. So that about wraps it up for this video. I hope you enjoyed it. I know I rambled a lot about particular topics, but I'm really passionate about these. And if there's any topic that you'd like me to dive deeper into, I'd like to make this more of a series where we can dive deep into subject mapping or deployment with Next, or how we do load balancing. And I can dive deeper in there and hopefully equip more people to build simpler microservice architectures. So thanks so much for watching. Be sure to give this a like and subscribe once again, and I'll see you in the next one.